The Curious Mind.
All right, let's dive into something that is fundamentally changing our world, the way we do science itself. We're talking about a massive shift away from the classic image of a lab coat and a microscope, and into a brand new era, an era completely powered by computation. So think about it for a second. When you imagine a huge scientific breakthrough, what pops into your head? Is it that lone genius splashing chemicals around until they shout Eureka? Well, that can still happen for sure. But the reality of discovery today, it looks a whole lot different. And honestly, it's way more powerful. You see, the new frontiers of science aren't just being explored out in the real world, they're being explored inside computers. What this really means is that major discoveries are now being pulled out of gigantic collections of data and modeled in super powerful simulations, sometimes before anyone even steps foot in a traditional lab. So to really get a handle on this computational revolution, we're going to break it down into the 4 huge pillars that are basically rewriting the rulebook for science. First up, our first pillar, artificial intelligence. The best way to think about AI in this context is as a kind of superpower prediction engine. It's incredible at spotting patterns in complex data that a human brain just could never see. So at its heart, what AI and machine learning really do is this. You feed them an absolutely enormous amount of data. I mean, just mountains of it. The system then teaches itself to see all the hidden connections and patterns in there, and then it uses that new knowledge to make stunningly accurate predictions when it sees new information. To see just how powerful this is, let's look at a problem that has stumped biologists for 50 years, protein folding. You see, proteins are the little machines that run our bodies, but what they do is all determined by their super complex 3D shape. And figuring out that final shape from just a list of ingredients was a ridiculously hard problem. And then along came AlphaFold from DeepMind, and it just completely changed the game. You literally feed it the basic sequence of amino acids, the building blocks, and boom, the AI predicts the final tangled up 3D structure. And once you know the structure, you know the protein's job. This is a massive, massive accelerator for things like designing brand new medicines. And the scale of this is just staggering. AlphaFold didn't just solve a few of these puzzles. It has predicted the structures for millions of proteins. I mean, this is work that would have taken scientists centuries and billions of dollars to do the old way. It's not just an improvement, it's a genuine revolution. Okay, so that brings us to our second pillar, quantum computing. Now, if AI is all about finding patterns in data we already have, quantum computing is about solving problems that are basically impossible for even the biggest supercomputers we have today. It all boils down to the most basic piece of information. The computer or phone you're using right now runs on bits. And a bit is like a light switch. It can be on or it can be off. A 1 or a 0, that's it. But a quantum computer uses something called a qubit. And thanks to the wonderfully weird rules of quantum physics, a qubit can be a 1, a 0, or somehow both at the very same time. Yeah, I know. This property is called superposition, and it's what gives these machines their incredible power. Instead of a normal computer trying out solutions one by one by one, a quantum computer can basically explore a huge number of possibilities all at once. It's like checking every path in a maze at the exact same time. And the potential here is just world-changing. Quantum computers could, for example, smash the encryption that protects all of our data today. But on the flip side, they could also let us perfectly simulate molecules, which would allow us to design unbelievable new materials from scratch, things like superconductors that work at room temperature, or super efficient batteries. Okay, on to our third pillar, data science. You see, with all this AI and new computing power, we are generating an absolute tsunami of data. And data science is the language we need to learn to make any sense of it. Just think about it for a second. A single run of a genome sequencer, or one night of data from a new telescope, can produce terabytes of information. That's not something you can just pop into a spreadsheet and analyze. This data explosion demands a completely new way of working. So to deal with this, scientists now have a new toolkit. Programming has become an absolutely essential skill. Languages like Python and R are the new lab benches for a modern scientist. And we've even seen whole new fields pop up, like bioinformatics, which lives right at that intersection of biology, statistics, and computer science, all built just to make sense of this data flood. And all of this brings us to our fourth and final pillar, the Internet of Things, or IoT. This is how the digital computational world actually connects back to the physical world. You can think of it like a global nervous system that's constantly collecting data. To put it simply, IoT is all about sticking sensors and internet connections onto physical things. For science, this could mean smart instruments in a lab or millions of tiny sensors scattered out in a forest, all of them automatically and constantly gathering data and beaming it back for analysis. And these sensors can measure pretty much anything you can imagine. We can now build these huge networks to monitor entire ecosystems in real time, tracking everything from tiny changes in soil moisture deep in the Amazon to the exact speed a glacier is melting in Antarctica. And the benefits here are just enormous. We get this nonstop, super high-resolution data that makes our climate models way more accurate. It can help us spot disasters like forest fires or floods before they happen. It can even completely automate experiments in a lab, which cuts down on human error and makes research go way, way faster. So we've gone through these 4 pillars: AI, quantum, data science, and IoT. What does all of this mean for the actual person at the center of it all? What does it mean for the scientist? Well, it means the very definition of a scientist is changing. It's not enough anymore to just be an expert in biology or physics. The modern researcher has to be a part-time programmer, a data analyst, a computational thinker. These skills aren't just a bonus anymore. They're becoming essential. So let's just tie this all together really quick. We've got AI, which accelerates discovery by making predictions. We have quantum computing, which will solve currently impossible problems. We have data science, which lets us understand all the information. And we have IoT, which collects that information from the real world. Together, these 4 things are building the foundation for a whole new era of science. And honestly, everything we've talked about today is really just the beginning. This whole computational approach is now starting to merge with other mind-blowing fields like CRISPR gene editing and synthetic biology. So the real question isn't just about what's changing now, it's about what incredible discoveries this new way of doing science is going to unlock next. It's only just getting started.
The Curious Mind.